To calculate the mole of hydrogen and oxygen, we first need to find their mass. So we looked up the density of the chemicals online. 0.0089 grams per milliliter. Step 1 is to find the mass of hydrogen used in the launch by using the formula mass equals density times volume. The mass of hydrogen would be 0.035 grams. Step 2 is to find the molar mass of hydrogen. According to the periodic table, the molar mass of hydrogen is 1.0079. But since hydrogen is diatomic, its molar mass would be 2. So then step 3 is to calculate the mole with the formula mole equals actual mass over molar mass. Here you would place 0.035 over 2, and that would give you the mole of 0.018 or 0.02. To find the mole of oxygen, we repeat these steps. Since we need to know the mass of oxygen in order to find the mole, we will find the mass by using mass equals density times volume. The density of oxygen is 0.001423 grams per milliliter. The volume is 200. Thus, the mass is 0.2846 grams. This would be the actual mass. And in order to find the molar mass, we do just as we did with hydrogen. We go to our periodic table and find the mass of oxygen, which is 16, but since it's diatomic, it would be 32. So now, in order to find the mole, we do 0.2846 over 32, and the mole would be 0.0089 or 0.01. Now you can see very clearly that the ratio between hydrogen and oxygen was 2:1. In order to get water, we must first write a reaction. H2 plus O2 equals water. In order to balance it, you would have to add a 2 in front of H2 and H2O, in which the reactants are 2H2 and O2, and then the product would be 2H2O. Both reactants disappear because when the rocket is ignited, these chemicals, oxygen and hydrogen, become water. However, since the spark contains so much energy, this water is vaporized. This water vapor is what increases the pressure of the water as it is shot.
Whoa! The best ratio was the 2:1 because it created water vapor, which increased the pressure inside the bottle and expelled the water. The ratio in the balance equation is also the 2:1 ratio.